So I'm recording this, okay? So this is very much like what you hear on the videos, right? So there. And you're going to put this in Blackboard. It'll be on the online help sessions, right? In their tab it says online help sessions, right? It works for you? Really? Jason, you still using that too? Okay. It's up on Blackboard as well. So anyway, okay. Who was first? Number 6. All right, here we go. Whew. Okay. Ready? Oh. Okay. So first off, it's properties of exponents, right? So let's kind of look at what we got. We have 16 times the square root of x, right? Now, I want you to see something real quick. This square root of x can be written as x to the 1/2. Do you understand? And that's the kicker here. And yeah, I got a negative exponent on there. But I'm going to hang out with that one for just a second, right? Whatever you want to do. So I'm going to take this 2, this power of 2, and I'm going to distribute this, right? Properties of exponents, right? Power to power rule. So this really becomes 16 squared, and 1/2 times 2 just becomes x. And now I still got y to the -1, right? Now, last step, cleaning everything up. 16 squared is 256, x, y. Because the -1 has to, y to -1 has to come to the top, right? No. Just the one. See, there's only y that's being raised to a negative exponent, right? Not the whole thing. If it had a parentheses out here, then I could flip it reciprocal, right? There. Now, I can go ahead and tell you, you're going to see ones like it. You're going to see properties of exponents. Guaranteed. Yeah. So anything raised to a negative power has to move. If it's in the numerator, it has to go to the denominator. If it's in the denominator, it has to move to the numerator. Okay? Negative power. Not just -1. It could be -2, -3, -4. It could be any negative exponent, right? But negative exponents, period. It's the negative exponent rule. So if it was raised to -2, it would be y squared. Yeah. Andrew.
So just because I'm kind of confused, 16 squared times x divided by y raised to -1.
Yep.
Can just be also multiplied by 1.
Well, 16 squared is 256, right? Yeah. There ain't nothing happening to the x now. That y to the -1 means it does not reside in the bottom. It needs to move to the top. That's it. And if it was in the top, it would go to the bottom. That's exactly right. Yeah. All right. So, we've been fighting hot and cold most of the night or day in here. I shouldn't say day. It's still about 75 degrees. Okay. Next. Number 8. Okay. Okay. So this one is very much like the previous one, except for I've got I've got power to powers, right? I got one that's positive and then one that is negative. Now, there's multiple ways I can do this. I can do this right off the bat going, you know what? Because this whole fraction is raised to the -2, then I can go flip it, reciprocal, right? Now it's raised to the positive 2, right? And then I've got this one right here, a to the 4th over 2 squared, right? Not, I just wrote, my brain's going crazy. Now, I can turn around and I can say that these powers are going to go in and touch these, right? So that's going to give me a to the 6th, 3 to the 4th, times a to the 8th, right? And 2 to the 4th. Y'all with me? Equals. This right here, top, is going to be a to the 14. Y'all agree with that? Because I'm multiplying, I'm adding these two, right? Okay, over. Well, 3 to the 4th should be 81 times, man, no, 81 times 2 to the 4th is 16. So what is 81 times 16, guys? Okay, so my final answer is going to be a to the 14 over 1296. Okay? So yeah. Yeah, in a minute. Any questions on this? Y'all good? I cannot stress, you're going to see properties of exponents. You got to be solid, especially with those negatives, power rule, and the power to powers. Okay? Yes, Olivia. 3 to the 4th is 81, and 2 to the 4th is 16. So, all right. Any questions on this one? Let me go back. Oh, geez, I do not want that. Get out. You said 9. All right. Adding and subtracting radicals, right? Adding and subtracting radicals. The one thing you got to make sure you understand about these are they have to have like radicals. Now, let's look at the first one. 14 square root of 6. I can't simplify square root of 6 because, let's think about it. 4 is my lowest perfect square, right? Well, 4 going to 6? No. My next one's 9. I'm done, right? So square root of 6 is as simplified as it can be. But it's a clue to what may be a factor of the one that's right beside it. 24. Hey, I know that this is really what? Negative 6 times the square root of 4 times the square root of what? 6. So I split 24, square root of 24 became these two, right? And look at that. There's that square root of 6, right? So square root of 4 is nothing more than 2. So here I've got negative 12 square root of 6, right? This little joker right here is just going to hang around until I get done with that. 14 square root of 6 minus 12 square root of 6 equals, ladies and gentlemen, 2 square roots of 6. Okay? Will you see that? Yeah, you most certainly will. Okay? Yes. Number 11. All right. You cannot have a radical in the denominator, right? And this happens to be a binomial, binomial down here in the bottom, right? You remember the conjugate? You remember that? What we're trying to do is we're trying to multiply top and bottom by the conjugate of this, which means we're trying to do a difference of squares. If you remember difference of squares, it's going to cancel the middle term and only leave you with the square of the first and square of the second one, right? So this really becomes 1 minus the square root of 3. And I'll put it on top so that I'm not really changing the value of it, because that's really 1, right? So when I got this, I'm going to show you a shortcut. We've taught you how to do this, have we not? So now I'm going to show you how to not have to worry about foiling this. It's the first times the first, last times the last. I don't have to worry about the O and the I, because the O and the I ain't going to be there. Does that make sense? And the FOIL, it's the first and the last, because it's a difference of squares. O and I, they're going to go to 0, right? You know, take my word for it. Try it. Work it out. It'll drop. That's like positive 1 square root of 3, negative 1 square root of 3. Those cancel. Okay? So what's 1 times 1? Positive square root of 3 times negative square root of 3. That's negative square root of what? 9. Y'all okay with that? Now, we know, or should know, that that's really going to be 1 minus 3, right? Okay, now let's go work the top up here. We're going to take that 5 in here. That's going to be 5 minus 5 square root of 3. And then 5 minus 5 square root of 3. And 5 minus 5 square root of 3 over negative 2, right? Okay, here's the tricky part. Every bit of this right here, you got to get that negative out of the denominator. So what you got to consider of it is, don't split it, but think about it in terms of splitting. What I mean by, I'm going to look at this right here first. 5 over negative 2 is negative 5. Do y'all agree? It's all going to be over. Yeah, okay, hold up. Just stay with me. And a negative make a what? So do you see how I've done this? Basically what you do is, you just change all the signs up top. So that positive 5 went to a negative. The negative 5 square root of 3 became a positive. Does that make sense? Now, you could have done this. And this was probably what Paul's alluding to back there. This is negative 5 over 2 plus 5 square root of 3 over 2. And if I recombine them, look what I got, guys. I'm right back to the same thing, right? So this is the part that will really kick your butt when you have a negative in the bottom. No. They're not going to have the green and the red. They're going to have one or the other, but not both. And my gut tells me it's going to be the red. It's going to be the red. So when you have that and it has that negative, just change all the signs up top and you're good. Yeah. That's right. Okay. Questions on that one? All right. Next. 12. Boy, y'all just going right down the line. Can I do something real quick? Because I did not tell my wife that I was going to be here till 9. And I'm going to get busy and forget about it. Then, yeah. Good. Now I'm not in trouble. All right. So, guys, this right here is number 12, right? So, this is just like the ones that we just done previous that were square roots, but these happen to be cube roots, right? So, you better set and go. And I hate to put one cube because it's always one, but that's 8, that's 27, that's 64, and this is 125. No, that's stuff you got to come up with. You got plenty of scrap paper. Like, I'll bring in about 250 sheets. Yeah, you got plenty of scrap paper if you need it. All right, so I got to simplify the cube root of 128, right? So I got to find one of these factors that would go into 128, right? Right off the bat, y'all see one? Yeah, sure do. The cube root of 64, and that would be what? Times the cube root of, man, look at that. See that thing right there? I know I can't simplify the cube root of 2, can I? But it helped me to get to where I'm going, right? So if you understand what it's giving you up front, it kind of points like National Treasure. You know what you're looking for? You can see the signs. So here, this becomes 4 times the cube root of 2 plus 3 cube root of 2. And when you got common radicals, you just add them. Treat them like coefficients, right? There you go. Okay. Questions on that one? Okay. Hold up. We got to give everybody a chance before we go back and repeat. Anybody got one you want to see that hadn't spoke up? Speak now, forever hold your peace. Okay. All right. That's number 14. First off, 81 is a perfect square, right? 361, that's a perfect square as well. If I think about this, that's 19. It's 19, right? So if you do it like this, go ahead and split it. Then that's going to give me 19m over 9 square roots of m. Huh? Remember that this radical, this index is 2, right? 2 goes into 2 how many times? Once. So one of those m, a pairing of those m's can come out, right? One pairing. All right. Y'all good? And can I simplify 9 over 19? Don't have a radical in the denominator. I'm good up here. Bada bing, bada boom. All right. Anybody that's not asked a question? Anybody? Yes.
Well, I've seen one in here, but like if there's a cube root on the bottom, like 1 plus the cube root
And it's not on here? I don't think it's going to give you one like that, but let's just say, let's say that. Let's for grins and giggles, this is just one made up, right? So it's the cube root of 9 under 2, right? 2 over cube root of 9. Well, I've got to rationalize it, right? Now, I need to get a perfect cube. So what do I need to multiply top and bottom by to get this to be a perfect cube in here? The cube root of 3. Because what that's going to do is give me 2 cube roots of 3 over the cube root of 27, which is nothing more than over 3.
No, he just made it up.
I don't think there's one like that, but I'll double check. I'm pretty sure that what I've got selected is a pretty good, but hey, yeah, if that radical's not a perfect cube, what do I need to multiply it by to get it? Because this is what I'm trying to shoot for right here, that 27, because that's a perfect cube. Okay. All right. Huh? Anybody? Okay. All right. Oh, yeah. Will you have one like this? Probably. Okay. First thing I'm going to do is I'm going to take that negative up here. Right up there, right? Okay. And I've got a fraction equal to a fraction, guys. Cross multiply. That's negative 4 times 4t minus 4 equals 8. 4t plus 8. And then I'm just going to distribute. That's negative 16t plus 16 equals 32t plus 64. And now it's just a matter of solving an equation, right? 48t plus 64. And of course, if I move that over, that should give me 48, right? I think. Yeah, negative 48 equals 48t. And of course, divide by 48. Should be positive. Mine to be a positive, but I come out with a t equal to be a negative 1. Your 48 would have been positive on the other side if you were dividing by negative 48. Yeah. So, yeah.
The only time we do cross multiplication is when you have two fractions set equal to each other.
That's it. Cross product. Because what you've got are two ratios set equal to one. You got a nice little proportion. That's really what you got. And you were taught way back when to solve proportion by cross products, right? Yeah. So, yeah. No, I'm going to tell you something. Listen to me. When you come up to these problems, when you look at it, if you're like, uh-oh, then you're going to be uh-oh on the final. If you're struggling on how to begin, if it ain't hitting when you look at that and go, how do I work this? If it's not coming to your thought like, boom, this is what I see, this is what I'm going to do, then you better spend some more time on them problems. Because you've got to be able to look at it, know what it's telling you, and have a plan of action of getting it done, right, to solve it. Because if you don't, guys, you can look at a math problem till the cows come home. Doesn't mean you're going to work it. I know it's multiple choice, but don't make it a multiple guess, right? That's so we're trying to end on a high note, right? We've been working this whole 8 weeks to end on a high note. So just remember, if it ain't clicking, you need to spend a little bit more time on it, right? From the review part, okay? From the review part. Okay, next. All right. Parallel to y equals 2x plus 5 and passes through the point 4, 3. If they're parallel, guys, line 1 slope happens to be 2 over 1. If they're parallel, then the slopes of these lines better be the same. Okay? Which is nothing more than 2 over 1. I write them out as a fraction because guess what? If I've got to say the perpendicular, then it's the opposite or negative reciprocal, right? So here's what I've got. The only thing I'm going to use is this, because they give me a point and a slope, guys, and it just told you exactly what to use. Here's my x, here's my y. When I plug those in, they have to change signs. The x and y have to change signs because it's y minus and x minus. So I've got y minus 3 equals 2x minus 4. And from this standpoint, guys, I got 2x minus 8 equal to y minus 3. I am adding 3 to both sides. So y equals 2x minus 5. Huh? No, I had to write the equation. They gave me an equation and told me to write the one that was parallel to it, but passes through that. Hold up. You got a question on this? Are y'all good with y equals 2x minus 5? Yes.
What kind of formula do you call that?
This?
Yeah.
Point slope form. Yeah, point slope form. And that's on your formula sheet. And that formula sheet can be found up in Banner under Final Exam Review, right? Or Final Exam Information or something. I don't know what I put on that, but it's up there. Okay. All right. This slope I just identified as the first line, and M2 is the slope of the second line. That's right. I just put little subscripts so I knew which was which. Okay. So good question. I can. Hold up. Anybody got any other question off this one? You probably going to have one of these that are like that. These going to be parallel, perpendicular 1. And you may have to do some stuff to the equation before you get there. So on this one, it's not in slope-intercept form, is it? And that's 1 there. So the slope for this one happens to be 1/3. So I had to do something to it before I could get it, right? Now, they want to know that it's perpendicular. So the slope for the second one, if it's perpendicular to the first one, has to be the opposite or negative reciprocal. So if that's positive 1/3, this one has to be a negative because that ensures crisscross. The reciprocal ensures the intersection at a 90-degree angle, which would be -3 over 1, which is -3. And then I'm right back into the same thing of here's a point and a slope. Write the equation. Yes. Some people say negative reciprocal. Some people say opposite reciprocal. It's the same thing. You got to have one that's positive and one that is negative. Amy, you got to have that so it does this. So it ensures a crisscross. So, all right. So that's y minus y1 equals m times x minus x1. Guys, when you're working these problems, you better write down the equation. If you don't write down the equation when you work the problem, your brain is not going to pull something it ain't done. Okay? There's a right way to prepare and there's a wrong way to prepare. You do not want to get on the final exam and go, crap, what did I write? What do I use? Because you haven't done it. If you think you're going to remember it, it's bad. You will, what you do not do, you will have to, you won't be able to recall it.
Did you divide by 3 to get rid of?
I didn't do anything. Oh, yeah, right here, I had to get in slope-intercept form, y equals mx plus b, right? They left a coefficient on that y to trip you up. They want you to see positive 1 and run with it. So, yeah, I'm going to tell you something. This test, this final exam is a departmental final exam. There's the right answer, the first wrong answer, and the second wrong answer. Do you understand me? It's a good multiple choice test. It is not blatantly obvious about what it is. So, but I will tell you this. Don't second guess yourself. There's a reason why your brain went down that rabbit hole to begin with. If you're prepared, stick with what you got. Unless you just definitively know you worked it wrong. Does that make sense? A lot of people can talk yourself out of answers. Think about why your brain went there. All right. And then just add one, right? So y equals negative 3x minus 5, right? Questions on that? Yeah.
The mx plus b, what kind of formula is that called?
Slope-intercept form. Yeah. Your formula sheet will have all these on there. They have them all on there. So. Okay. Any questions about the perpendiculars?
I know we've already passed 24, but how did they get 14 over 5 on 24?
Was it on that list that I sent out today or yesterday? Was that particular one on there?
I didn't get to see.
Is number 24 on that list, guys?
Okay. Yes, it is.
Yeah. Okay. Oh, gosh. I'm just going to do this. Okay. I just copied this over. Write the equation line that passes through 102 with a slope of 4/5. So, do you see that the 2 change signs and the 1 change signs? And then when you distribute through, you get negative 4/5 x plus 4/5, and you got the minus 2, right? Well, you're going to add 2 to both sides, right? So when you're adding 2, you got to think about how would 2 look like if it had a denominator of 5. Well, what's 5 times 2? 10/5 is the same as 2, is it not? So 4/5 plus 10/5 gives me 14/5. So you just find the common denominators, right? And that's really what they done. Okay. Okay. Any questions?
How you got 10 over 5?
Okay. This one has a denominator 5, right? Okay. So let's think about this. I got 4/5 plus 2 over 1, right?
Yeah.
Okay, so I need to make sure that they have the common denominator, right? So I need to make sure that this 1 times 5 is 5, right? So I need to get it to be there. So I got to multiply the bottom and the top by 5, and that gives me 5. Yeah, that's what. Those are skills that I hate to say we take for granted, but we normally take for granted because we just type them into our calculators, right? But those are that's a skill set that's really good to get back. Okay. It's a good question. All right. Now, anybody that's not asked any question. No, that's you need to see this one. It's not on there? Well, okay, but okay. The slope is undefined. What have I given you from a strategy standpoint that's going to help you? Slope, man, that's exactly right. Man. Yeah. That's, I know, but it's a good one just in case you have one like this, right? Because, I could ask you a perpendicular parallel question, right? Really a perpendicular to a horizontal line and a vertical line, right? I could do that. So this is zeros, right? So it's a vertical, right? So the slope is undefined. It passes through 0.23. What is the equation, right? It's x equals the x value. Because for no matter what, the x is 2 for that, right? Which would provide you with. And that's really what that's saying. So, yeah.
What do you call a
Horizontal
horizontal line?
line. No, Ben, it's just horizontal line. It's a special case, okay? It's a special case on it. This one just happens to be a vertical, right? And I know I got a special case because there's well, it's undefined. You're right. The slope is either going to be undefined or 0 for the special cases. I was thinking about how would you know if you were looking at it from an equation standpoint. You got one variable, right? One variable. So, yeah. All right. Okay. Anybody that hasn't asked a question, anybody that has asked to work a question. 29? Yeah. Is that what you needed? Oh, my bejeebies. Y'all like, we got to have that one. Yay! Okay. So, can I work it as a system? Or y'all, do you want it worked out as a table? What if I do both? That be okay? Yeah. Y'all ain't gonna argue. Be like, sure, whatever you want to do, Mr. Palmer. Nothing about it, right? All right. They set it up as a linear, right? So, but I'm gonna set it up as a system. Now, I'm gonna let X be something and Y be something. So, chemistry teacher needs a 30% salt solution to mix a 30% salt solution with a 70% salt solution to make 20 gallons, quarts, 20 quarts of a 40% salt solution. Okay, did I burn it? There. How many quarts of each solution should the teacher mix to get the desired? Okay, now I'm going to say this one, X is a 30%, right, solution, and Y is the 70% solution. And these are amounts, right? Correct? So, guys, we're going to write a totals. Okay? So, X plus Y equals 20 quarts. Okay? And then my next equation is going to be this. It's a value. It's a value portion of it. And what I mean by value is this. We have 30% solution times how much we got plus 70% solution times how much we got equals, we know what this ought to be, right? 40 and what? 20, right? 40 times 20, right? You with me? Which would give me what? 80. Y'all okay with that? Yeah. Yeah. 800. Yeah. Thank you. Yes, Olivia. Oh, you pick. But once you make that notation, you got to stick with it. It'd be the same thing. I'd come up with the same answers, but my X and Y should be flipped. Does that make sense? Because they're going back to different variables, right? Yeah. So what I've got is this. I've got X plus Y equals 20 and 30X plus 70Y equals 800. Guys, I'm going to sit here and multiply the top one by what? Negative 30, right? So it's going to give me a negative 30X minus 30Y equals negative 600. And that's 30X plus 70Y equals 800. And when I add those, that's 40Y equals 200. So Y equals 5, right? That'd be 5 quarts. And at that point, I know that I've got 5 quarts that are 70% solution. So if I got a total of 20 quarts and I got 5 of them in the 70%, how many's in the 30? 15 quarts, right? Okay. So, but you've got to see this X plus Y equals 20. That's a how many total gallons, right? I shouldn't say total gallon. Not, it ain't gallons. My brain's stuck on gallons for some odd reason. Total quarts, right? And then the bottom one is the percent solution times how much we have, plus percent solution times how much I have. And I know how much I got of the mixture that I want, right? 20 quarts of the 40%, right? Which gives me 800. And then it's just a matter of that. Now, let's do this thing again. But this time, item, amount, percent, total. Okay. So with the tables, I do this. Item, amount, and of course that's in quarts, right? And then percent solution, and then totals, right? So I've got a 30 and a 70, a 30% solution, a 70% solution, and then I want to end up with a 40% solution. Well, I don't know how much I got in a 30, do I? So we're just going to say X, right? That's an unknown. But I know it's 30%, right? So that gives me 30X. Okay, these two multiply. Now, I don't know about this one yet, but I know that that's 70. Would y'all agree? Is it hot? I turned it down. It's still like it's fighting. Whew. All right, let's try to get a little bit cooler. Okay. All right, guys. So here we go. I'm going to hold off on totals because I don't know what this is. But I know I got 20 quarts here, right? 40%, and that gives me 800. Well, if this is 20 and that's X, this has to be 20 minus X, right? So this would be 70, 20 minus X. I've taught it a lot of different ways. Sometimes I'll just take the approach, instead of going across, I'll go, okay, I got a mouse. Okay, I don't know how much 30% solution I have, but I do know how much of the 40 I got. So that's X, that's 20, and this has to be 20 minus X. That's an algebraic technique, right? And then, of course, these are just the percents, and then you multiply them to get the totals over here. Now, what that's going to do is set up the linear equation that they have as part of the solution, right? So it's these two added together equal to, guess what? So that's 30x plus 70 times 20 minus x equals 800. Ladies and gentlemen, when you solve that, you will get the same thing that we got in the above solution. Okay, I promise you. Now, I'm not for sure that they've got a percent solution on there, but it was on my list of ones to make sure you could do. I can't remember what the final, because it changes every year. I could tell you back 5-6 years ago, I guarantee you'll have a mixture on there. I can't remember. So, but it's on there. So I done something back then. I don't know what I done. Yeah. Now, because they used 0.4 too, didn't they? You either keep the percent solutions as whole numbers or keep them as decimals. It doesn't matter. It's still going to come out the same thing. Yeah. Huh? Okay, but what is X? Of the what? Yeah. I haven't solved this one yet. But when I do, that'll be the... What does that give me? 15's X, and X happens to be who? 30. And that's what we got up there, right? Let me go back to here. Yeah, that got 15. Yeah, we're still same. So either way, you're going to be okay on that. Okay, let me go back here. It doesn't matter to me how you work it. Pick away, but know how to do it. That's the key. Know how to do it. All right. Anybody that's not asked a question? Anybody that's not asked a question? Yes, ma'am, Miss King. So the 29 was the one that bothered y'all? Oh, okay. We want 30, right? Okay. Let me... All right, we worked one of these way back in the beginning of the semester, bless you. So let's kind of look at it. If you pay $66 for a car radio after receiving a discount, 25% discount, what was the price of the radio before the discount? Well, guys, the price of the radio, original price, right? We're going to say is X, right? Okay, so we're going to say X minus some 25% times X, right? 25% times the original price will give me how much that's off, right? And that is equal to, guys, $66. Now, I can go ahead and tell you, this problem, if it's 25% off, then 75% of the value is equal to $66, right? And that 75% of the value has to be as a decimal. And then you just divide by 75, right? And you get X equals to what? 88. All right. You've got to, here's what you, because I'll just be honest, sometimes this problem right here trips me up when I haven't looked at it in a while. Because I'm thinking, oh, man, which ways to go. But if it's something off, you got to think about how much is still there. And that's what 75 comes. That's why it's the original price is X minus its discount, which is 0.25 times the X, the original price, right? That's going to give me how much is there, 0.75X, right? Yeah? Sweet. Sweet. All right. Anybody else that has not? Shay, I haven't heard from you tonight. You okay? Or are you just going to sit and just, okay, that's good. That's good. Okay. Everybody's at different places. So we're able to get to different places, hopefully on this final exam review, right? So I'm okay with that. All right. So guys, the floor is open again. Second round of questioning. Go. 36. Yeah. All right. So guys, the square root of -1 equals I, right? So what we're going to do is rewrite square roots that have a negative underneath it as that square root times I, right? Or I times that. We're going to pull that thing out. So this is really -1 times the square root of -1 times the square root of 4, right? That's what this all comes down to. And I've got -4 times the square root of -1, right? That's where these are coming, right? Times the square root of 25. Guys, -1 times I times 2. That's going to give me -2I. Now, if I come over here, that's -4 times I times 5. And that gives me -20I, which gives me -22I. Okay? Do you see how I broke this out? This was the key information I had to understand right there. I had to understand that. I didn't have any other choice but to understand that. Okay. Questions? Okay. Next. I love this one. You hate them? Who said hate them? What? Oh, come on. Look right here. This is not bad. Look. You got to know this. I to the first is I. I squared is -1. I cubed is -I. And I to the fourth is 1. Okay? So what I'm doing is I'm going to rewrite these in terms of I to the fourth. I to the fourth raised to some power, right? And my remainder is going to be my answer because I to the fourth is 1, guys. So my remainder, 1 times my remainder is going to be my answer. So how many times will 4 go into 15? 3 times. Well, that gives me 4 times 3 is 12. So it leaves me with an I cubed left over, right? Okay, this is 1 times negative I equals negative I. Done. Yeah? No? How many times will 4 go into something? It'll go into it evenly, which means no remainder, so the answer is 1. It either go into it with a remainder of 1, which would just be I. A remainder of 2 would be negative 1. A remainder of 3 would be negative I. Boom, that's it. That's all you're looking at. Okay? Well, you probably have one of these. Yeah. I'd be prepared. But look to the things I just got right here on the right-hand side. That's the key. And guys, I want to tell you something. All I have to remember, I to the first is I. I squared is negative 1. That's something that I can get to I cubed because that's just these multiplied. I can get I to the fourth because that's negative 1 times negative 1, which is positive 1, right? So I can get back to this very quickly. And if you can't, write it about 15 times and it'll be there. Okay? All right. Y'all are stressing me out. Looks on y'all's faces. Except for Paul. Paul's back there is just chilling, man. All right. Okay. Next. Man. I tell y'all, but this is one of my fun nights. You know why? Because I get set work problems. And I haven't worked these in like forever. So it's just sitting and nerding out. Okay. Find the discriminant and then state how many solutions there are and the nature of the solutions, right? So when they say discriminant, they're talking about how many times it touches the x-axis, right? So is it going to touch it twice, once, or none? That's the key. So if it touches it twice, then you got 2 real numbers, right? If it only touches it once, it's just 1 real number. That vertex is sitting on there, right? Right? And then if it doesn't touch it at all, then you have 2 imaginary. But your discriminant, and that's what your discriminant is, if your discriminant is greater than 0, it's 2 real numbers, right? If your discriminant is equal to 0, 1 real number. If your discriminant is less than 0, 2 imaginary solutions, right? So here we go. We got A, B, and C. A is 2, B is negative 6, and C is 7. So I got negative 6 squared minus 4 times 2 times 7. So that is 36 minus, that's 8, that's 56. So it's a negative what? 20? So that's what discriminant equals, negative 20. Well, think about it. If you take the square root of a negative number, what do you have? Imaginary, right? So, yeah, I know discriminant's not taking the square root of it, but look at it in terms of where it is in the quadratic formula. That's everything underneath that radical, right? Yeah. Yeah. Okay? And the reason why it would come out to be 1 real root is if your discriminant came out to be 0, if you take the square root of 0, then you're losing the plus and minus. It's just the b over 2a part, right? Yeah. Yes, ma'am. It's too imaginary because it came out to be a negative, right? So.
On the paper, it calls it 2 complex solutions. Is that the same?
Yeah, 2 complex solutions is the same as 2 imaginary solutions. Complex means complex numbers, right? So, yeah, good question. I'm not going to tell you who asked that question at the same time or said the same thing that you said at the same time. But it is.
I could probably guess.
Yeah, you could probably guess. Y'all are just about in sync.
That's my girl.
All right. Y'all ready? Next. Malik, smile, please. 46. Here we go. Whew. Yes. Okay. What? It is. It's not as hard as what you think it is. It's much harder. No, it's really not. I'm just being facetious. Don't pay me no attention. This is number 46, right? Okay. I got a radical, right? Okay. How do you solve a radical? By the power of the root, right? But you got to make sure it's isolated, correct? So this kind of looks scary, but it's really not. This is a 4th root, so I'll raise everything to the 4th power. That means this drops. 2 to the 4th is 16. Now it becomes a cakewalk. All right? But you got to be able to see that. And if you don't see that, then that's the problem, right? So plus 4. So 3x equals 20. Divide by 3. X equals 20 over 3. Ladies and gentlemen, that is a legit, right? Yeah. And if you plugged it back in, it will work. Because 20 minus 16 will give you, or 20 minus 4 is 16. 16 4th root is 2. So we're good. Yeah, 20/3 is good. And it's a fraction. Have y'all had many fractions like those? I don't know. Y'all have worked your homework. I haven't worked it. It has been a minute or two, hasn't it? So, all right. 40? Y'all okay? Okay. So solve this by the quadratic formula, right? So let me make sure I'm grabbing right there. All right. So they told you what to solve it by. What you want to use? I don't know. And the reason I don't know is this. Let me do this. That is negative 10. And then it's got to be negative 8. So no. I can't find factors of negative 10. So that'd be, if I do 10, that's 1 and 10, 2 and 5. And I can't find the difference. That's going to give me 8, right? So yeah. If they say solve by quadratic equation, if they say solve by completing a square, what are you going to do? Quadratic equation, right? Okay. Or quadratic formula, I should say. So, yeah. Can't do it by factoring. So, but you still need to see it? Yeah, okay, good. Yeah, not a problem. This is where most people are going to make a mistake. is the negative 4AC. I grab that minus 4AC, I make it a negative 4. And it is, when I'm multiplying A times C, I'm multiplying it by negative 4. Okay? So when I get a number, that's the number I'm running with its sign. So A equals 2, B equals negative 8, and C equals negative 5. Okay, so when you substitute things in, make sure that they go in parentheses, because that makes things a lot easier when it comes to order of operations and will not catch you in a sign error. And when you do that, that gives you 8 plus 64. That's negative 4 times 2 is negative 8 times negative 5 is plus 40, all over 4, which is going to give me 8 plus or minus the square root of 104 over 4. Now, what do you think is going to happen to the 104? Huh? They're going to simplify that radical, guys. They're not going to put it as a decimal. Do you understand? I'd very much be shocked if they did. Okay? So I'm going to take the square root of 104, and I'm going to say, okay, what are 2 factors? Well, 4 go into it. How many times? How much? 26? Okay, if 4 goes into it, well, 16. Will 16 go into 104? Y'all remember that? I said 4 goes, automatically try 16, because 4 and 16 could be multiples, right? So square root of 4 times square root of 26. Ladies and gentlemen, that's 2 square roots of 26. So that's going to go right back in here to the 8 plus minus 2 square roots of 26 over 4, which is going to say this number, and that number all have to find something to go into it. What all goes into those numbers? 2. So that's 4 plus or minus square root of 26 all over 2. And that's what you got to do. All right.
So you don't keep going to 4 and 2?
I can't do the 4 and 2, because that 2's over that 4, and it's over that square root of 26. That's over both of these things, right? Here and here. So if I simplify it and go, oh, that's 2 plus minus square root of 26, I just changed what its value is, right? So I can't do that. Right. Sir? What? 2? It can't be. The B's 8, right? Negative 8, which makes it a positive 8, right? It could be. Okay, hold up. Let me see if they just hold up. Let me. Okay. All right. So watch what I'm about to do. You got to understand that this, if I do this right here, then it's going to leave me with this. Those are the same. Okay. What's in the green and then the red here are the same. The green I just left as a big fraction, right? But guys, if you get down to here, and this is an answer choice, which it could be. I mean, as far as I can't remember. It could be. It's not that far of a stretch to go, oh, boom, right? So, yeah. All right. Next. Woo, all right. Oh. Okay. I'm going to make this really, really easy. End of story. Period. If you ever see a y squared, it's never going to be a function. Period. Now, that equation right up there, that's the equation of a circle. It's centered at 0 with a radius of 3. That's what that is. So, yeah. If you ever see a y squared, never, ever will it ever be a function.
What if it was x2 plus just y? Would it be a function?
Yes, if it was an x squared and the y was raised to the first power, then you're looking at a quadratic, right?
Oh yeah, true.
Yeah. So here's the question that was asked. If you're looking at this, then yeah, you're looking at a quadratic because the y has the power of 1, right? So as long as the power of y didn't go above 1, you got a pretty good chance it's a function, right? So what about a graph? What are the looks for a graph? Y'all remember this? This way, or what? Like that, right? This, or that. Y'all remember that? Yeah? Yeah, all right, good. And vertical line test, right? What about a table? What if it was a table or a list of ordered pairs? What do you got to look for it to be a function? What do you got to look for it not to be a function? Huh? X's can't repeat. Andrew, you're perfectly correct on that. Right? I'm looking for my X's not to repeat. If they do, then it's not a function, right? So in that particular problem, we just hit all 3 looks, correct? Can't be a y squared. If it looks like this, or a circle, right? A backwards C, and then X's can't repeat. Because if they do, then it's not a function. You got stacked points, right? You got stacked points. Ooh. All right. Next. Yeah. Sure can. Oh, yeah. This is good. This one's it's not as hard as what it appears to be. And I'm going to show you why. Y'all remember if something it's a fraction of a power, right? Y'all agree? Okay, so it's a cube root of something being squared. Would y'all be okay with that? The 3's the root, and that means x minus 1 squared. So, guys, when we get rid of a square root, we square it. We get rid of a cube root, we cube it. Well, this one, all we have to do is say raise it to the 3/2 power, right? Because if I raise it to the 3/2 power, guys, look what happens. This power raised to that power, 3 times 2 is 6 over 3 times 2 is 6. 6 over 6 is 1, right? So it drops it, cancels it. Now, you can sit here and go, well, 9 to the 3/2 is nothing more than, burn it. Not that, guaranteed. It's the square root of 9 cubed, right? The square root of 9 is 3, and 3 cubed is what? 27. Now, could you get that without having to know that? As far as knowing that I had to rewrite it as that. Yeah, you type in your calculator 9 raised to the 3/2 power, it's going to give you 27. So the working smarter there is to know that that's the route I would take. Is 9 to 3/2 power, right? Add 1, x equals, guess what? 28. Okay. Next. Nope. Scratch 49. Why? It's an absolute value inequality, right? That's where I had I wouldn't say a brain fart, but I went blank. I had and in my mind, and it was I think the problem was an or, right? I couldn't get it. It's basically, here, I'm just going to show you something real quick. And they write it out as a compound, but I'm going to show you just in case you ever have to write one, you'll know how to do it. Because you might leave this class and go somewhere else. Absolute value less than, that means it is an and, okay? If it was absolute value greater, then it would be an or, right? And you just have to do it like this. You'd have a positive and a what? Negative, and that would be 2x plus 3. Switch to inequality and multiply the right by -1, and then you're solving it. And you know it's an and, so if you graph it, it's only where they intersect, right? And then you either have to write it in interval or inequality, right? There you go. But that's mine. So I take that one, okay? So, yeah, you won't see that one, okay? Okay. Questions? Which one? Oh, domain question. Find the zeros and domain. All right, so it's a two-parter, right? So which problem is this now? 54, and write that there. Okay, so if I have to find the zeros, right, that's really the same as saying x-intercepts, right? Y'all agree? So if I got to find the zeros, then my y equals 0. How did I get rid of square root? I'm going to take this 3x to the other side. And then, of course, divide by 3, so x equals 4/3, right? That's the 0. Okay. Now, if I'm looking for the domain, then I am taking the radicand, which is everything underneath the radical, and setting it greater than or equal to 0, right? And then I am doing nothing more than solving it, right? So that's divided by -3. So that's x less than, because it flips it, right? And that'd be 4/3. Let me rewrite that, because a negative and negative make a positive. And of course, when you do an interval notation, that's 4/3, and that's a closed dot going this way. So negative infinity to that. So there you go. And if I had to write it as inequality, then it would be this. Interval is that. 0 is this, right? Whew.
How did you know how to do greater than equal to 0?
the square root of function, if you're looking for the domain, the parent function, the parent square root function is from 0 on. So it has to be greater than equal to 0. And that's where that comes in, Olivia. So that's a good question. That'd be something I'd want to make sure I kind of jotted down inside my notes or whatnot. The domain, why is said equal to greater, the radicand said equal to greater than equal to 0. It'd always be like that based off of the parent function. The parent function drives that. All right. Next. Hey, we're halfway through, right? It's 104 problems, right? 154. Hey. Any takers? Anybody? 55? Is that one that I have on there? Yeah? Okay. So they want this one too? Domain and, okay, 54 and 55. Domain and solution, right? Huh? Okay. Well, if I can grab the right thing, I put it over there and I can explain how to work it. Okay. So if you want the 0, so we said y equals 1 over x minus 3, right? So 0 equals 1 over x minus 3. Guys, watch this. It's not as hard as what you think it is. Cross multiply. 0 times x minus 3 equal to 1, right? Look what's about to happen. My variables drop. Does my left side equal my right side? So the answer is, guess what? That's right. So for an x value, it's not going to have one, right? It's no solution. Now, domain. Well, we know that the denominator contains a variable, right? So we got to find out what its restrictions is. So x can't be equal to 3, right? Okay, so let me move some stuff over here. And then this can go here. And then there, right? So let me draw a line right here. Okay. And now we'll draw a line right here. So if I'm going to give you the domain and 3 can't be part of it, then I have to tell you it's negative infinity up to 3, and then 3 to positive infinity with a union, an OR, right? Note that I don't have a bracket on any of these. No bracket on these because 3 is not included. We done one like this kind of on the quadratic. You remember when we had the quadratic in the denominator and we done it and we had all these, we had like we had 2 U's, did we not? We had 2 U's because we had 3 different regions, right? Okay. Good. Next. Yeah. All right. Sketch the graph is going to be which graph does it, which graph is the piecewise, because it's a multiple choice, right? So if you remember when we done the homework on these, I took away the graphing parts, right? but you had to choose. You did still have ones that here's piecewise what graph went with it, right? So let's kind of talk about just where would you see things roughly, and I can show you some what I call Etch-a-Sketch, okay? And this is what I mean by that. Said sketch it and then write the domain. Okay, so first off, if I am looking at it from a standpoint of just the X and Y axis, if I'm looking at it from that, now I'm looking at -2, right? That's my player, -2 right there, right? So it's going to have something that is open. It'll be a line that comes up with an open dot, right? Now I'm underneath the x-axis, and the reason why I'm underneath the x-axis is if I went to graph this, it'd be at +1 on the y-axis, right? So I'm just kind of etch-a-sketching it. And then on this one, it's got to be a negative, right? So I know it better be something that has, and I'm just putting it right here. It could be above it that does like this, right? Does that make sense? It's got to look like the blue and the green. Now, it may be situated somewhere differently on the graph. Does that make sense? But I know it's got to look like that because I've got a positive slope and I have a negative slope, right? I have an open dot on the positive and a closed dot on the negative. Y'all agree? Yeah. Yeah. You're going to be able to see it on this one. You're going to see that right there would be at -3, right? That's right. Why? It doesn't exist past -2, right? Doesn't exist. See, if I go to 1, well, even if I go to 0, right? 0 is x. Is 0 less than -2? So it doesn't exist there. It gives you a false statement, right? So I know it's going to look something like that. One coming up with an open, one going down with a closed. Okay, so that's the combo I'm looking for. And then I would look at where are my y-intercepts. That'd be my next thing I'd go to, right? Now, look at the domain. Guys, this is every value less than -2. And this is every value from -2 on, right? So we're looking at it from a standpoint of piecewise, right? So tell me a value in the domain that's excluded. There's not one. You're exactly correct. So the domain for this would be -infinity to positive. Now, I will show you this. Look right here. If I took that right there away, if I made that right there go away, guess what I would have? I'd have a open dot at, well, open dot, I just closed it in, didn't I? An open dot that says it can't exist there, right? And then we'd have a union thing. Does that make sense? But that would be two open circles on the same point, which would cause a not equal to, right? So just realize that. Okay. Okay. Next. I got it as far down as it'll go. I am suffering up here, trust me. Yeah. But I will tell you, it's a lot cooler up front than it is in the back. Nope. No, I just think these right here are on a different system than that one over there. Hence the two heating and air controls back there in the back. All right, wouldn't do that. I hope. Let's see. Oh, okay, yeah. Could be. Write the parabola in standard form, which really is vertex, right? So so H equals negative B over 2A, right? So we got A is equal to negative 2, B equals 8, right? So let's see, negative 1 times 8 over 2 times negative 2. And I'm going to tell you something, guys. You see this right here, negative 1? I used to just stick a negative out there with parentheses. I now put in negative 1 instead of just a negative. I have found that when I'm teaching my ninth graders, I have more success of them getting the right signs and the right vertex from it. Okay. So if I can get them to do it at 15 years of age, then how much more successful should you be? Much, right? So that is negative 8 over negative 4, which is 2, right? So that's the H values 2. Now I'm going to plug it in here. So 2 squared is 4. I'll just write it out again. So that's negative 8 plus 16 minus 10. So that's negative 8 minus 10, which is negative what? 18. So I got an H and a K of 2, negative 18. And then my A is negative 2, right? So when I write this, it'll be negative 2x minus 2 squared minus 18. So what do they have on the answer key? Who wanted this one? Would you have a sign problem?
Wouldn't it be negative 2?
Huh? Where? I'm
Negative 8 plus 16 is 8 minus 10.
yeah, negative 8 minus 10. Oh, no, my bad. I just saw my mistake. Thank you. You're right. You have a good set of eyes. I made a mistake. Hold up. Negative 8 plus 16 is positive 8, which would give me negative 2. So when I plug that in, that would be there. What did they use? 18? They done exactly what I done. Just okay. Hold up. It can't be a positive 2 times that because the A is negative, right? The A of the standard form is the same as the A in the vertex, right? Those A's are identical, period. Yeah, just quick. This one right here, right there. When you plug the H in, it should be minus. Y'all check my work. Boom, boom. Huh? Okay. Okay. Next. Y'all don't give out on me. Come on. I've been teaching for 3 hours and 10 minutes. Let's go. Yeah, sure. Heck. Yeah. Huh? Ah. Okay. Will you have one like this? Yeah. You going to have one. Okay. So, and we had one of these in homework, did we not? So, yeah, it was similar. Okay. A ball thrown in the air from the top of a building. That's the key. It's not on the ground, is it? From top of a building. You know how tall that building is? 8 feet. Because that constant right there, that's how tall it is. At time equals 0, you 8 feet above the ground. All right. How long does it take to reach the maximum height, and how long does it take to fall to the ground? Okay. If it started from the ground initially, which would mean that it wouldn't have a constant, the constant would be 0. Then once you found the maximum time or time it took to get to the max, you double it, and that would be what it would be, right, for the hitting the ground. But you can't on this one, because if you look at it from a graph standpoint, this baby is not starting here. It's starting up here. So it's in, I hate to say mid-flight of the parabola, but it's there, right? So, and there's a part over here that we're not seeing, correct? That we can't even take into account because it doesn't exist. So, first things first, H equals negative B over 2A. Because we got to, in order to find how long it took to get to the maximum height, we got to find the H of the vertex, right? So, that would be negative 1 times 24 over 2 times negative 4.9. And that's going to give me negative 24 over 9.8, right? Okay, so that, what does that give me? It's going to give me a time that's positive, right? H is what? What's 24 over 9.8? 2.44 seconds. Okay? 2.449. Okay, good. Or 2.45 if they round it to 2. So that's how long it took to get up there. Now, but we got to figure out how long did it take to hit the ground again. Well, when it hits the ground, that's like hitting on the x-axis, which is a 0. Ladies and gentlemen, you solve the quadratic. You do the quadratic formula. Okay? Now, y'all need me to do the quadratic formula on this one? Yeah? Okay, y'all going to have to help me with some numbers, okay? So, let me pull this back. I got A equal to negative 4.9, B equals 24, C equals 8. So, negative B plus minus square root of B squared minus 4AC all over 2A. Now I can rock and roll. So that is negative 24 plus minus 24 squared, which is, that's exactly right, minus 4 times negative 4.9 times 8 all over 2 times negative 4.9. All right. Whew. So I'm going to move this over here so I can have a little bit more room. Negative 24 plus or minus, that's 576 plus 156.8. That's what this comes out to be. All over 9.8, right? Nope. No, you're right. Sorry, my bad. That's going to give me negative 24 plus or minus the square root of 732.8 over negative 9.8. Now, guys, I want you to kind of see something real quick. What is the square root of 732? We'll move this up here. Square root of 732.8. 27.0. So I'm going to approximate 27.0703 into this equation, okay? And what that's going to give me is negative 24 plus 27.0703 divided by negative 9.8. And I would have, I got to change colors, negative 24 minus 27.0703 divided by negative 9.8. And this bottom one is going to be the one that's going to give me. This top one's going to give me a negative number, right? Negative value. That's no good, right? We're not building a time machine. So somebody quickly do negative 24 minus 27.0703 divided by negative 9.8 and tell me what it is. 5.21. And that's 5.12 seconds. Guys, that's a good problem. I'll just go ahead and tell you. That is a Mac Daddy good problem. Now, I want to do something real quick, okay? Because in 2 minutes, class is technically over. So what I want to do is I want to walk y'all over to where the final exam room is, and it's in this building. It's J202. Now, what I'm going to do is this. I'm going to
Yeah, I got problems with those.
okay. All right, so let's look at it. This one is actually a rate of change problem, right? And so what you got to make sure you understand is it is so let me move this over. Near the surface of the moon, the distance that an object falls is a function of time. It's given by d sub t equals 2.6667 t squared, where t is in seconds and d sub t is in feet. So the output's in feet and input's in seconds. So if the object's dropped from a certain height, find the average velocity. That's the average rate of change, right? The slope of the object when t equals 1 and t equals 2. So basically what we're doing is this. We're creating a t-table of 1 and 2, right? X's is 1 and 2, right? So what I'm going to do is go 2.6667 raised to the, not raised, times 1 squared, and that's going to give me 2.667, right? Right? Okay, now I'm going to do it again, but this time I'm going to put in 2 squared. So that's 2.666 or 2.6667 times 4. Let me get a calculator. Yeah, there it is. So what that gives me is that's going to give me 10.6668. Now, so I put that here. Okay, from 2 to 10, if you look at this, you might as well just go ahead and say that's 8, right? And that this is 1, right? So 8 over 1. Yeah, it's change in y over change in x, right? Yeah, we'll go back and look. Right? 8 over 1. They come out to 8.001, right? Feet per second. Because this is 2.667 and 10.6668, I just said 2 to 10 is 8, right? And 8 over 1, boom, done.
So you just subtract top and bottom?
Well, I said I'm at 2 and I'm moving up to 10. How far did I move? 8, and it was positive, right? So yeah. Or you could do y2. You're more welcome to do y2 minus y1 over x2 minus x1. And then you've got these are ordered pairs, right? And you'll get the same thing. Okay. All right. What you got?
78.
Yeah. Yeah, that's a good problem right here. You'll have one like this. Yeah. Huh. I mean, look at the problems I told you to prepare. How many of those are word problems? I mean, it's not that they're just asking you to do stuff with it, right? So, you better.
On the formula sheet, do we bring our own? Or you
No, I'll have a formula sheet for you.
Oh, okay.
Sure will. Now, I just gave that to you so you can go ahead and get practice of going ahead and making that. So, this is a compounding interest problem. So, I know it's A equals P to the 1 plus R over N raised to the NT. So, I normally do this A, P, R, N, and T because I like to pull this information out. He made an initial deposit, that's the principal, right? That earns 3.6%. Now that interest rate has to be put in as a decimal. So that'll be 0.036, right? Semi-annually means twice a year. Semi-annual sale, right?
Okay, yes,
Like Macy's, JCPenney's, Belk's, they all had semi-annual sales. And then 20 years. Okay, now I'm just substituting these things in. 6,500, 1 plus 0.036 over 2. And then that's 2 times 20, which is going to give me 40, a power of 40, right? Okay, so what I need for you to do is you take 0.036. Let me hit clear. 0.036 divided by 2, hit enter. Then add 1, hit enter. And what I got right here is 1.018, right? Now, I'm going to raise that to the 40th power. And I'm going to hit enter. And that leaves me, just so you can kind of see on your calculator, I'm not going to clear anything yet. That leaves me with 6,500 times 2.0413, right?
Which power that I'm gonna take?
Carrot top, right above the division sign. That's going to give me,
You say times 40, right?
yep, no, raised to the 40th power. And then times 6,500. That's going to give me $13,268.58. Yeah, that's one of the numbers I came up. 2.0413. Yeah, that's what I multiplied 6,500 by. But if you'll just, when you do this, 0.036 divided by 2, hit enter, add 1, hit enter, raise to the 40th power, hit enter, times it by 6,500, hit enter, you always come out with a correct answer. do not try to round these off and try to plug back in stuff, and because you're introducing error. Mm-hmm. Yeah. See, you're either going to have compounded interest or you'll have continuous interest. And how you know the difference? It'll say it. It'll say compounded interest or it'll say continuous interest, right? So it's going to say that. So you don't have to worry about that. Continuous is A equals PE raised to the RT. Continuous interest. Let's see. That's continuous. Oh, it is. That's the same E. Yeah, that's the E, which is 2.71828. That's the constant exponential, right? I don't know. We don't have to worry about variations. I mean, we don't have to worry about that. So, okay, what you got?
79. Mainly got products with those works.
Okay. Okay. So, Kyoko has $10,000 that she wants to invest. Her bank has several investment accounts to choose from, all compounding daily. Daily means what? How many day? Daily means 365 in a year, right? 365, right? Her goal is to have 15,000 by the time she finishes graduate school in 6 years, to nearest hundredths of a percent. What should her minimum annual interest rate be in order to reach her goal? Okay. Now, that's right. Daily. Okay, so her goal is to have 15,000, right? That's her goal. Equal to 10,000. 1 plus, we don't know what the interest is, but we know that's 365 days, right? And that this right here is 365 days compounded times 6 years. So 365 days is 2190. Okay. So there's a couple of things we're going to do first. We're going to divide both sides by 10,000. So really that right there becomes 3 over 2, right? You simplify that becomes 1.5, right? 3 over 2. 1 plus R over 365 raised to the 2190 power. Now, here's the kicker. In order to get rid of the 2190 power, you've got to take 3/2 and take it to the 2190 root, right? Now, my calculator will allow me to do that. If I do 2190 and then I can do that. And what I get as a decimal is 1.0002 equals 1 plus R divided by 365. Okay. So I'm on minus 1. So that's 0.0002 equals R over 365. Guys, look right here. It's a tough one. I'll just go ahead and tell you. But I'm going to cross multiply. Well, let me back up. That's equal to R over 365. Let me just go ahead and say I'm just going to multiply both sides by 365. And that's going to cancel. R equals 365 times that. Let's see. So, guys, that's 0.0676. And if I move it 2 places, that would be 6.76%. So you would have to get 6.76%, period. Okay. The hardest thing is to raise it to, or take the root, the 2190 root of that, right? But you should get something that is 1 point something. The reason why you should get something that's 1 point something is you need this one over here to cancel it out. Because you don't have an interest rate. That interest rate ain't going to be above 20-something%, right? So you know it's got to be less than 1, right? So this right here, 1.02, that tells me, okay, I'm on the right track. It's some crazy math, but I done it right. And then I minus 1, which gave me 0.002, times both sides by 365, because to get rid of R is being divided by 365, multiply both sides by 365.
How you put this in a calculator? 2190.
All right, so type in 2190. Okay, hit the math button, which is a button up on the left-hand side. Go down to number 5 and hit enter. And then type in 3 divided by 2, close parentheses.
Oh, so I gotta write that. I gotta write in parentheses.
Yeah. When you done that, number 5, you should have opened up a parentheses, right?
It did.
Hang on, let me see. Oh, no. You hit enter. 2190 math number 5.
Oh, okay.
Oh, then 3 divided by 2, close parentheses.
Oh, okay.
Now, minus 1, and then multiply it by 365, and you're good. Yeah. Uh-huh.
Well, it's giving me 0.675.
Yeah.
You write it. You put it up to
Ju-
0.76.
But I moved it. See, that interest rate is as a decimal, but when you change it to a percent, you got to move it 2 decimal places, right? So from a decimal to a percent has to be 2. So, yeah, let me see. My calculator, here's why. My calculator is 1.0002. It's rounding it to 4 decimal places instead of, so you've got, when you do it, you're going to get 7.3%, and because that is introducing error. So let's see how you got to do this. You got to find the root. Okay, so 2190, second there. Okay, you see that button right there, the caret top? Okay, so you're going to do 3 divided by 2, close parentheses, and that gives me that. Minus 1, and then times 365. All right.
It's giving me that.
All right, let me do this real quick. Yeah, that's it.
So I just round it up to 76?
No, you got to multiply that by 100. Move your decimal 2 places to the right.
Oh, okay.
See, you're getting this number right here in green. You just got to change it back into a percent. That's what you got to understand. This is what you got. Now you got to change it back into a percent. So that's like multiplying it by 100, right? Yeah.
Okay.
Yeah. All right.
LN and stuff, and it'll give me the answer.
No, you're not going to do LN, right?
Oh, I was looking at 84.
Okay. So, like, let's see, 84.
But they're both kind of the same weird graph, except one's FX without the LN and stuff.
All right. Why am I not? Okay. Yeah. You're just going to pick your LN of, just put X values and just kind of, you're just going to look at it and give yourself what it was, X value and what the Y value is so that you could pick the graph that's going to give you that. If you had one like that. But they tell you that noting, well, they say create, okay, but they're showing you that this 2 minus X, but we really didn't talk about, create an asymptote at X equals 2. You just got to just pick some X values and evaluate it to get points, and then you're just checking your graph to see which one gives you those, right?
Yeah.
The easiest one would be, when you do 0 and then 1. Those are things that I would do. So, yeah.
Okay.
Yeah. All right, guys. Any other ones that y'all have? Is that one that it's on the list? Okay, so we're going to condense it, right? So here we go. So first things first, anything that's out in front of the log has to go back up in here because those are powers, right? So that's what I'm going to take care of first. So I'm going to go log X minus log of Y to the 1/2, right? Plus log to the Z, or log Z of 2 raised to the 3rd, right? All right, so here we go. This is going to give you log of X over what? Y to the 1/2 is nothing more than the square root of Y, right? Now, do we put a parentheses and then times it by Z cubed? No. That Z cubed has to be in the denominator. Okay? So it'd be X minus that, right? And I'm pretty sure, if my memory hasn't escaped me, that, oh, they are, what did I do? Hold up. This is it. Let's see. You can't do that. Huh. Okay, hold up, guys. Okay. They switched these. But that's in order. I wouldn't have done. Well, okay, hold up. Let's think about this. Okay, this plus log of z cubed. Let's just break it down like that. Now this becomes log of x z. Oh, if I can talk and write at the same time, I'd be pretty good. Log of x z cubed over square root of y. So we put together this part and then brought this down, and then it's a little bit easier to see. Don't do moving like they were showing. Okay. Yeah, that's my bad.
Right answer.
Yes, this is right here. Yeah, that's the way to do it. Combine these, and then it's plus that, and you know that these two plus would be multiplying, which means that would go up top. You wouldn't. I just threw it down below. I just wasn't thinking. So something about almost 4 hours worth of math kind of makes your brain crazy. So yeah. Okay. 80. All right. So that one's gonna have to be the last one for the night because I got to get packed up, and then we got to walk over there and see. Okay. And I put this one on there? Okay. Okay. So in 2006, 80 deer were introduced in a wildlife refuge. In 2012, the population had grown to 180 deer. The population was growing exponentially, so they write in algebraic expression or function representing. Okay, so they want us to write an exponential function. So what you have to understand, in 2006, we're going to say t equals 0, right? So we're going to create a t-table. So we're going to say, hey, 0 and then 2006 to 2012 is 6 years, right? So there was 80 deer when we introduced them. 6 years later, there was 180 deer. Okay? So what we're going to do is this. We're going to say y equals a times b to the x divided by y equals a times b to the x. And the reason we're going to do that is this. We're going to put the bigger one up top, so the output's 180.
Minus on top and
That's the times. That's the times right there. That's the multiplication. So a times b raised to the 6 divided by the output for this one's 80 equals a times b to the 0. Okay, and we're going to divide these. 180 divided by 80. So 180 divided by 80 is 2.25. Okay, so that's going to give me 2.25. Now a over a crosses out, right? That leaves me with b equal to 6 minus 0, which is going to give me 2.25 equal to b to the 6, right? So anything raised to 6 power is I got to take 6 root. So I'm going to take the 6 root of my 2.25, and that's going to give me a base. 1.1447 is my base. Okay. So here's what I got. I know that when I write this equation, a times b raised to the t, that this has to be initial value, right? So I've got it. I know what the initial value is. In 2006, we were at 80 deer. That's when we introduced them, right? So, and we just found what the base was. So y equals 80 times 1.1447 raised to the t. And that's it. That should be the answer right there. So let me check just to make sure. They got 1.1. Yeah, that's the same. I went out a little bit. 1.1447, right? They put 1.1. Yeah, we're good. We got the same. They rounded to 3 decimal places, so 1.145. I went to 4. Okay, so nothing difference from there. All right, so I'm going to